Well, hello, Honors Physics. This is Chapter 4, Video Part 2. So, here we go. Last time we were talking about Newton's laws, Newton's first law and Newton's second law. To remind you, Newton's second law was F net force equals ma. So what we have here is we have Newton's second law. The net force is going to be equal to the mass times the acceleration. Newton's first law, remember, was the law that said that objects do not want to accelerate. Objects want to stay at rest. Objects at rest want to remain at rest. Objects in motion want to remain in motion at constant velocity. Things do not want to accelerate. So Newton's second law therefore says that for something to accelerate, you need to force it. You need to force it. Well, that brings up another interesting point, and that's this little guy right here, mass. So we can think of mass. Another fancy word I want to use here is the word inertia. You can think of mass as an object's natural resistance to being accelerated. Inertia is what that means. Inertia is a resistance to being accelerated. So an object has a mass, that would be its resistance to being accelerated. So when I apply some net force, I have to overcome the object's resistance to being accelerated, and I will get some acceleration. So if you think about it, this makes a little bit of sense, right? A low mass object is fairly straightforward to, a low mass object is not that difficult to accelerate. A large mass object is difficult. I mean, it's pretty easy to make your iPad accelerate. It would be quite difficult to make your entire house accelerate, okay? So there we have that. The next thing we want to talk about is the difference between mass and weight. We want to talk about the difference between mass and weight. We use these two terms in our English language interchangeably. We talk about mass and weight interchangeably. We have to be very specific here when we talk about this in terms of physics. Mass and weight are not the same thing. So here's the short version. Weight is a force. Weight is a force that is equal to the force of gravity. Weight is a force and it's equal to the force of gravity. Okay? So we'll use the symbol big W for weight for right now. So we would say that weight, if I could remember how to write, weight is just equal to the force of gravity. That turns out they're in the opposite directions. Let me explain further. The force of gravity is going to be equal to negative mg. The force of gravity is going to be equal to negative mg. Why is that? Well, net force equals ma. Net force equals ma. And if the only force is the force of gravity, then that would equal mass times the acceleration due to gravity. Now I'm calling this negative because the force of gravity pulls you downwards towards the ground. Gravity makes you go this way. Negative. Okay? Weight is going to be equal to the positive of gravity. So you can think of weight as equaling, I should have said this before, the absolute value of the force of gravity. So let's look at how that would be. Let's go stand on our friend the scale. So here's us standing on a scale. And the scale, no matter how we want to think about it, the scale does not actually measure mass. It reports back the mass. So when you look at the scale and you see the number it says, it's telling you how many pounds you are or how many kilograms. It's telling you mass. But the scale has a little spring inside. And what it's doing is it's measuring the force of gravity. Gravity pulls you down to the earth. The scale measures how much you're squeezing the spring. So the scale is directly measuring the force of gravity, and if you convert the force of gravity to a mass, it can report back the mass. Well, if you want to know your mass, take the force of gravity, divide it by g, and you get mass. So that's what the scale does. So how does this relate to weight? Well, let's draw a free body diagram for us standing on the scale. We'd have, the force of gravity is pulling us downward. When I stand on a scale, I personally don't accelerate. And if net force equals ma and the acceleration is 0, that means the net force on me when I'm standing on a scale is 0. Well, if the net force is 0, there has to be something canceling out that force. There has to be some other force. And that force is going to be the force from the scale. In other words, gravity's pulling me down, the scale is stopping me, so the scale is pushing up on me. And the scale is pushing up on me such that the force from the scale plus the force of gravity, right, has to make 0. Well, that means that we have the force from the scale plus the force of gravity, which we just learned was negative mg, and that has to equal 0. So that means the force from the scale equals positive mg. The force from the scale equals the absolute value of the force of gravity. Cool. The force from the scale, that force the scale exerts on us, when we use the word weight, what we mean is this. What we mean is this. What we mean is the scale pushing up on us. That's what we mean by weight. When I use the term weight, I mean that vector. And it is exactly equal to the absolute value of the force of gravity. So your weight is just the force of gravity acting upon you. I hope that makes some sort of sense. What we're going to do up at the board once you guys are done watching this video is you're going to see a really clever scheme for weight loss. Mwahahaha. Well, hope that's clear, and we'll see you in a few minutes.